Hey, this is Mr. Kim. We're going to do a screencast here for how to do a plane mirror ray tracing. And so we're going to use ray tracing a ton for this unit and the next one with lenses, mirrors, and for right now, we're talking about a flat mirror and how you see images back behind that mirror when you're standing in front of a mirror. For example, when you're in your bathroom, you can see a second version of yourself back behind that mirror. And so to kind of begin, we're going to draw a mirror. It's pretty large, right in the middle of our page. And we want to figure out exactly the rays of light and how they're behaving as they hit off an object approaching a mirror to help us to kind of see an image back behind the mirror. And so for right now to start, I'm going to draw an object that's in front of the mirror. And this is an actual real object that's in front of the mirror. And we're going to figure out how light rays come off of this object, approach the mirror, bounce off, and then in our minds create a fake virtual image back behind the mirror. And whenever we do these ray tracings, we're always going to follow the laws of reflection, which say that the incoming light rays will hit a mirror and the angle of incidence will always equal the angle of reflection as it reflects off of that mirror. So if I go to this picture down below, there's a ton of different light rays coming off of our object, and it's going to reflect off of the mirror following the law of reflection, and where all those virtual light rays meet back behind the mirror is where the image will be formed. And so we're trying to do that today here too in our own drawings. And so to start, I'm going to kind of at least set a groundwork for us. I'm going to say that since I know this is a plane mirror, to give my mind some kind of frame reference if I'm doing this right or not, if I measure from the actual object to the mirror, that's how far the object is from the mirror. So that's the DO, and that should be the exact same distance away from the mirror that the image is on the other side. And that's only true for plane mirrors for right now. That helps me kind of get an idea of where this image should be formed. So I know that for plane mirrors, the DO is equal to DI, or if I want to say it a different way, the object's distance to the mirror is the same as the image's distance to the mirror back behind that mirror. So when we get started with our ray tracings, I'm going to do the first two in green here. But I want to figure out where the tip of this arrow is going to go back behind the mirror. And so I'm going to draw a line. It can go anywhere along this entire mirror. And so there's a ton of rays of light. I'm just going to say I'm going to pick one ray of light going up and towards the right, towards the mirror there. And so there's my incident ray hitting the actual mirror. And I'm going to draw in now a reference line. This reference line is the normal line, and this is not a ray of light I'm trying to show. This is just going to be for me to help me to get equivalent angles of incidence and angles of reflection with this green ray of light. So I'm going to dash that line to show it's not a real ray of light. And now you can kind of see my angle of incidence with my incident ray and that normal line. And I know that the angle of incidence equals the angle of reflection. So I'm going to try to draw this next green line exactly the same angle as the incident angle was for my reflected angle there. When I do that, I want to make sure it's as close as I can get. You'll use a protractor on a quiz or test. But for right now, though, I'm just going to estimate this is pretty much the exact same angle of incidence as I'd have for reflection. So there's my reflected ray going out and away from the mirror there, and there's my angle R. And again, those two angles should be equivalent to one another. Another light ray that's coming from that tip is going to be just going straight towards the mirror. I think this is a simple one we can use right now. So here's a line that's going to go from our object's tip, and it's going to go right to the mirror, perpendicular to the mirror. When it does that, the angle that that perpendicular line makes with the normal line is going to be 0 degrees. And so when it reflects back off the mirror, it'll come back at 0 degrees as well too. So that incident ray is traveling the same path as the reflected ray for this ray of light. And I want to figure out, like, when these two reflected rays bounce off the mirror, where do they converge? And so I'm going to kind of show, like, here's my reflected ray for the light green guy going up and to the left, and then my bottom one's just going to the left, and those two rays will never converge on our side of the mirror. But they do converge somewhere. They converge back behind the mirror, which is why we make a virtual image. And so I'm going to draw those reflected rays back behind the mirror, but because they're virtual rays and they're not really real light rays, I'm going to dash these as well too to show that these are not real light rays. These are actually virtual rays drawn back behind the mirror that our brain interprets to be there, but they're actually really not physically meeting in a real place. So I'm going to draw back both of those reflected rays back behind the mirror, and again, dashing both of these guys again because they're not real light rays. They are reflected light rays in the virtual space back behind the mirror. And where those two guys intersect and converge, that's where the tip of the arrow is going to be. Perfect. We have a conversion point. I know where the tip of the arrow should be back behind the mirror. I'm going to do the exact same thing for the bottom of the arrow. So to know where the bottom of the actual object is going to be on the other side of the mirror, I'm going to draw an instant ray of light going from the bottom of the object towards the mirror there. And then I'm going to draw another normal line from that actual point where the ray of light hits that mirror. Sorry, my mirror is kind of getting moving with notability here. So I'll draw a normal line to give me some kind of reference to where that's going to have an angle of incidence hit the mirror. And so I'll dash this line again because it's not a ray of light. It's just going to be a reference point for me to know that angle of incidence right there. And I'm going to try to draw the angle of reflection that's going to come off that mirror for the reflected ray. That's pretty much the same angle of incidence as before as well too. And I think that's kind of close, right? And so there's my angle of reflection right there. And likewise, how I did above, I'm going to draw another ray of light coming from the bottom, going perfectly perpendicular to the mirror from that bottom of the object there, and it'll reflect likewise exactly on that same path as well too. And just like before, I'm going to figure out where these two light rays converge, and those two reflected rays don't converge on our side of the mirror again. So because they don't converge on our side of the mirror, I'm going to trace back those reflected rays that we drew back behind the mirror. And again, one more time, just to emphasize, I'm going to dash those lines because those are not real light rays. Those are the virtual rays that my brain thinks is where the light's coming from as I look into a mirror. And so there's my two reflected rays being traced back, and I'm trying to get these as perfect as possible without a protractor, but I think we're pretty close right here. And so I'll draw this one last time. And once we figure out where those two light rays converge, that convergence point is going to be where the bottom of the actual object is going to be. And so if I think about that bottom of the object being where those blue light rays meet and the top of the object being where the green rays meet, I think we're going to figure out where our entire object should be back behind that mirror in terms of its image formation. And so I'm going to put a black dot now kind of where those convergence points are, and as I do so, I think that the very top point here, we're going to show that we are trying to get the tip of the arrow right there. Sorry, my notability is kind of going crazy right now. But there's going to be the tip of our arrow where those two light rays converge on top. On the bottom, same thing as well too. And now I can draw my image. It's going to be upright. It's going to be pretty much the same size as before too. But it's back behind the mirror. And if you look too, the DO is pretty much equivalent to DI. The distance from the object to the mirror is equivalent to the distance from the image to the mirror as well too. If it's back behind the mirror, it's a virtual image. And I'm going to say it's RSU, which stands for right side up. It's not inverted. It's not upside down there. And that's going to be how we do a plane mirror ray tracing. So we've got a ton of things drawn out here. I need at least two rays of light from the top to show where the top is going to be. Two rays of light from the bottom to show where the bottom is going to be, and drawing out where the image actually is. And I'm going to label too, just for good habits, what type of image it is. It is virtual.